Okay, welcome back to my channel, guys. So today we'll be doing our chemistry form 4 chapter 3 questions. So these questions can be quite easy and say, so now let's start with the question first. Diagram shows the photosynthesis process for the formation of glucose in green plants. So as we know, green plants, it requires carbon dioxide gas and also water in order to produce our glucose and our oxygen gas. So what does the first question say? The first question says, write the empirical formula of glucose. Okay, so the empirical formula for glucose, empirical formula itself already tells you something. It tells you that, empirical formula means showing the simplest whole number ratio of atom of each element in a compound. So simplest whole number ratio, remember the keyword there is whole number. So let's write it down first. We're trying to spam this question. So empirical formula for glucose. Of course, first thing we need to know is that the chemical formula of glucose. So the chemical formula of glucose is C6H12O6. So the simplest whole number ratio means we're gonna simplify them. So each of them gonna simplify 6. We'll end it up with CH2O like this. Okay, so now we'll be moving to another question. Next, state one difference between empirical formula and molecular formula. Okay, hang on for a while. Right now, I'll be going down there. I'll be writing the definition for our empirical formula instead. So it will be more obvious for us to understand the concept between empirical formula and also our molecular formula. So the definition for empirical formula is of course it's a chemical formula, so we write first it's a chemical formula that shows the simplest whole number ratio lie here. Ratio of atoms of each element. You don't just ignore the atoms and just leave it right there. You'll get 0 marks. Whole number ratio of atoms of each element in compound. There you go. You only get 1 marks for this. If the question asks you itself, like the difference between molecular formula and your empirical formula, then probably you'll get 2 marks. Okay, so right now, we'll do another one by changing color, our molecular formula. For our molecular formula, it will be just opposite. It's also a chemical formula, of course. It's a chemical formula that shows, for empirical formula, it shows what? The simplest whole number ratio, right? But for molecular formula, opposite. That means it will show the actual number ratio of atoms. So you can write shows the actual number ratio of atoms each element in a compound. There you go, 1 mark, 1 mark. Next, we go back up right there. So what it says is, state the difference between empirical formula and molecular formula. Obviously, we know that, empirical formula shows the simplest whole number ratio of atoms, while molecular formula shows the actual number ratio of atoms. So basically, these 1 marks means you add it up together, which means you have to write, empirical formula shows the simplest, empirical formula shows the simplest whole number ratio of atom of each element in a compound. Wow. Listen up. While molecular formula shows the actual number ratio of atom of each element in a compound. You just have to mix both of these together. This is where your 2 marks starts to happen. Okay? So we go back up and we start writing. I'll change green color, so it will be more obvious. Empirical formula shows the simplest whole number ratio of elements of each of atom. Let me erase it. Of atom. Wait. Of atom of each element in a compound. While, see, what I'm trying to do is I try to mix both of them together. While molecular formula shows the actual is the keyword, the actual ratio of atom of each element in a compound. Done. That's your 2 marks. Next, we go to question C. Write a chemical equation of photosynthesis process. So obviously, the hint is already right up there. The moment when I saw the picture, it's actually a big hint already. Why? Because see, they already tell you the chemical right up there. So what you have to do is you just have to copy and paste down there into the question and make it into a chemical equation. So of course, we have our carbon dioxide gas, we have our water in order to produce our glucose and oxygen gas. So write down. But if you notice, right, there's actually 2 marks there. So the other marks comes from where you are able to balance your chemical equation. So meaning if you are not able to balance your chemical equation, you're only able to get 1 marks. Okay. So this is your hint. Go back to question C. Our carbon dioxide gas with our water forming into our glucose and also our oxygen. Okay. So in order to balance, right, actually we need to calculate one by one of them. There's actually a technique to do so, but because this video not gonna be too long, so I'll probably just skip to the answer. So I'll use blue color to balance the equation to get the second marks. 6 for carbon dioxide, 6 for our water, and 6 for our oxygen. And if you calculate one by one, you realize that my oxygen is the same number, and my hydrogen, like carbon dioxide, is also the same number. 6 carbon dioxide. Okay. 6 times 2, 12. 12 hydrogen. Nice. Well, nicely balanced. And how many are there? There is 6, 6, 7, 8, 8. There's a total of 8. 6, 7, 8. Yes, 8 oxygen. Nice. You get a second marks. So this question done, we go to question D. What is the percentage of mass by carbon in glucose? Okay. Percentage of mass, there's actually a formula for you to remember. If you do not remember the formula, that means you totally get 0 marks here. So what is the percentage? Percentage, remember percentage always times 100 first. Always times 100 first. So here, percentage of mass of carbon in glucose, like carbon in glucose, right? So we are finding percentage, how many percent of carbon in our glucose. So of course, it's actually a fraction. We need a fraction here. A fraction times 100. So of course, obviously, our carbon will be putting upside there, up there. And also our glucose will be putting down there. So what is it? It's of course our mass. Okay, it's of course our mass. It's of course our mass. So mass of carbon, It's not given. Is it given? The mass of carbon, is it given? Let me check. Oh yeah, we are, sorry, we are finding the percentage of mass of carbon, but look, what we have is our mass of glucose, right? So right now, we try to hunt them into the formula, basically substitution. Mass of carbon we are finding. Percentage of mass of carbon we are finding. But the mass of glucose, we have it, right? The mass of glucose basically means our relative molecular mass. Means we sub everything inside according to the glucose formula. So C6H12O6, right? C6H12O6. C is 12. C is 12. O is 16. H is 1. So C is 12 times 6 plus O, C6H12, H12, 1 times 12. C6H12, 1 times 12. O6, and O is 16, 16 times 6. And then remember the times 100, if not, you get 0 marks. Then your answer will be 40%. 40% after you times the percentage. So meaning, right, there's 40% of carbon present in your glucose. Then here you go, that's your 2 marks. Okay, so right now we move to another question without further ado. Okay, what is an, okay, come on. Compound X consists of elements carbon, hydrogen, oxygen. Carbon, hydrogen, oxygen. Carbon, hydrogen, and also our oxygen. Okay, what is an element? Come on lah. In SPM, right? You don't tell me that you don't know what is atom, what is an element. Okay, so element, there's nothing much to explain about. Element is basically just a substance that consists of only one types of atom. That means there won't be any other atoms present. Okay, so write down. Only 1 marks. Only 1 marks. That means if you can't remember this, you're gone in your SPM. Okay, it's a substance that consists of only one types of atom. There you go. That's your 1 mark. Take it. Don't waste it. Okay. Next. Okay, here. Oops. This question, right? A lot of students are not able to do it. Why? Because they don't really understand the concept of our empirical formula. Like, what's empirical formula for? Actually, empirical formula is just a simplified version of our molecular formula. More like what? More like you make it in a simpler way to explain it to your scientists. You know what I mean? Okay, empirical formula. Now, what it says, compounds consist of, okay, we know that compound X, from the question itself, it tells me what? It tells me that, oh, this compound X consists of carbon, hydrogen, and oxygen, CHO, okay? So, in SPM actual exam, they might not prepare you this thing. They might not prepare you your CHO, or they might not even prepare you percentage number of moles of atom, mole ratio, or whatever stuff. They might not prepare for you, which means you need to draw it by yourself. But in this case, they already prepare for you. Why? Because if you look closely, you realize that A, percentage is not given upside. It's not given up there. However, it's given right here. That means from percentage itself right there, we need to find the number of mole first, the mole ratio, and also to determine our empirical formula. So without further ado, let's see what else the question said. Determine the empirical formula compound X. Next, it's given, of course, our relative atomic mass, our hydrogen, carbon, and also oxygen. So number of moles, of course, number of moles, I'm not gonna explain in very details here, but obviously what we will be using right here is mass divided by molar mass, right? Number of mole, mass divided by molar mass. Number of mole, mass divided by molar mass. Okay, this will be our formula. So, of course, this is our molar mass. So right now, I'll be using red pen to do so. Number of mole, mass divided by molar mass. So the percentage, we take it as mass. We just take it as mass. So for 48.65 divided by, this is carbon, right? Divided by 12. So what we get is our 4.05. This will be our number of mole. Of course, number of mole, the unit is moles. Okay, just 4.05 mole. Next, for hydrogen, of course, hydrogen, our molar mass will be 1. So whatever divided by 1 is equals to itself. So we can just write 8.11. 43 point, next, for our oxygen, 43.24 divided by how much? Divided by oxygen, 16. Okay, sometimes it's the exam, right? They won't provide you the molar mass, which means, right, you have to remember, oh, oxygen is 16, carbon is 12, while hydrogen is 1. Usually, the more you do, you remember it. Eventually remember it, okay? So for the 3.24 divided by 16, what you get is 2.70. So now the mole ratio, please remember, mole ratio, what happened is you pick one of the smallest number right upside of the number of moles there, choose the smallest one, and then take all of them divided by it. So for example, for our number of moles for carbon will be 4.05, right? And for hydrogen will be 8.11, and for oxygen will be 2.70. So from three of these, the smallest one, of course, it's 2.70, right? So what I'm going to do is I'm going to take every of them and divide it by 2.70. So this is what I'm going to do. 4.05 divided by 2.70. Okay. And then for this, 8.11 divided by 2.70. Next, 2.70, sorry. 2.70 divided by 2.70. Of course, this one will get 1. 8.1 divided by 2.70. How much do we get? We get 3. 4.05 divided by 2.70, we get 1.5. This is our mole ratio. But remember something or not? Remember what I said? Oh, empirical formula, they basically means simplest whole number ratio of atoms. Simplest whole number. The keyword already, the definition itself already tells you that a simplest whole number ratio. But look at this. Look at this. Is it simplest whole number ratio? Is it even a whole number? No, it's not a whole number. It's 1.5. Right? So what you're gonna do is takkan you divide. If you further divide, you won't even get a whole number. But instead, what I'm gonna do is I times it, I multiplied it, and make it into a whole number. That's when my real empirical formula starts to happen. So 1.5, what I'm gonna do is 1.5 times 2. What I'm gonna get is a whole number, 3. Next, 3, of course, if 1 times 2, others also confirm times 2, right? So 3 times 2, what I'm gonna get is 6. 1 times 2, of course, 2. So you realize that the simplest mole ratio of atoms for our carbon will be 3, hydrogen will be 6, and oxygen will be 2. So of course, our empirical formula will be C3H6O2. That's your answer. But here, a lot of students, or even myself, I used to make these big mistakes where I forget to put the empirical formula. I forgot to label it, and then I write it down. It's just that, yes, you get your marks, but if you didn't write empirical formula, like the final one, you basically will tolak by one mark like this. So nobody wants that to happen, because it's not that you don't know, but you forget to write down. So empirical formula, in this case, you write the same way as I do. Empirical formula will be C3H6O2. Now, if you want to hantam your mole ratio inside, right, it will be what? C1.56301. Okay, it doesn't make sense because empirical formula is only for whole number. It's only for whole number, okay? Look back into our previous page. It tells you everything already. So this is why our teacher always told us, hey, memorize the definition paper, memorize the definition, everything. Either physics, biology, chemistry is the same thing. Why? Because sometimes, kadang-kadang, either the formula for maths, for physics, the formula itself, the definition itself already tells you something, tells you some keywords, some important points where you can't miss, or even helps you to understand more. Okay, so thank you so much for watching, everyone. So we'll go to the next video. Thank you.